If you've ever dealt with a massive data warehouse, you know that feeling when a huge query just brings it to its knees. Well, today, we're going to pull back the curtain on how Azure Synapse Analytics is specifically engineered to handle that kind of pressure. And it all starts with one big question.
Right? It's a massive challenge. When you're talking about petabytes of data, you can't just throw bigger hardware at the problem. The old school architecture just hits a fundamental wall. So what Synapse does is it completely rethinks the process from the ground up. The secret sauce isn't just more power, it's a totally different way of thinking about how to process information.
And that new way of thinking is called massively parallel processing, or MPP for short. Instead of trying to build one single, super powerful computer to do all the work, MPP is all about teamwork. It's the ultimate divide and conquer strategy, but for data. So here's how that actually works. You've got one control node that basically acts as the brain of the whole operation. It takes your query, breaks it up into a bunch of smaller jobs, and then hands them out to an army of compute nodes. Now here's the crucial part. Each of those compute nodes works on its own little piece of the data, on its own local storage, all at the same time, in parallel. Once they're done, they just send their partial answers back to the control node, which stitches it all together into the final result for you. This whole divide and conquer thing is a huge shift from the systems most of us probably grew up with. So to really see just how different it is, let's put it side by side with a traditional model.
Okay, the biggest difference really just boils down to how they access storage. With traditional SMP systems, you might have a bunch of powerful CPUs, but they all have to go through the same shared storage to get data. Think of it like a 10-lane highway suddenly merging into a single toll booth. It doesn't matter how fast the cars are, you're going to get a massive traffic jam. With MPP, every compute node has its own storage. There's no traffic jam because every single car has its own private lane.
And that quote really hits the nail on the head. That single point of access to storage, that's the bottleneck. It's the fundamental thing that limits older systems. If you've ever sat there for hours just waiting for a query to finish, this is almost certainly the reason why. The entire MPP architecture is designed from the ground up to get rid of that bottleneck.
So getting rid of that storage bottleneck is a huge win. But this architecture unlocks something even more powerful, especially in the cloud. The ability to completely separate your computing power from the data itself. Let's dig into what that actually makes possible. This right here is the absolute core of why cloud systems like Synapse are so incredibly flexible. Because your compute power and your storage aren't permanently tied together, you can scale them independently. You follow? Need more number crunching muscle for a really big job? No problem, just spin up more compute. You don't have to rearrange all your storage to do it. This decoupling is what gives you true elasticity. But it does create a new kind of challenge. To get this challenge, think about it like this. Imagine your data is 10 glasses of water. Your compute power is 2 athletes who need to drink it. Scaling your compute is the easy part. You just add more athletes to the team. But what if you need to scale your storage by adding 10 more glasses? You can't just set them on the table. You literally have to repour and redistribute all the water evenly across all 20 glasses. And in the data world, that redistribution process is incredibly slow and painful. Okay, so this whole data redistribution thing is a classic, nasty problem in distributed systems. How does Synapse give you all that flexibility to scale your compute power up and down without forcing you to pay that massive penalty every single time? And here is the brilliantly simple solution. Synapse just fixes the number of glasses of water at 60. That's it. Your data is always distributed across these 60 storage units, no matter what. All right, now that we've got the architectural blueprint, let's walk through what actually happens step by step when you hit enter and run a query. So let's follow the life of a single query. First, your query hits the control node. Think of it as the system's quarterback. The control node figures out the best parallel plan to run it and then sends the relevant instructions out to every single compute node. And here's where the magic happens. Each one of those nodes runs that query, but only on the slice of data it owns locally. They do their work and then send their partial results back up to the control node, which handles the final step of aggregating everything into the single, neat answer you were looking for. It's really just a beautifully coordinated dance. So what are the big takeaways from all this? First, scalability. This whole setup means you can easily add or remove compute power on the fly to match whatever your workload is. Second, elasticity. Since compute and storage are separate, you can literally pause your compute and only pay for the cheap storage. That's a massive cost saver. And third, concurrency. By killing that central storage bottleneck, a whole lot more queries can run at the same time without tripping over each other. This architecture is just tailor-made for the crazy demands of a modern data warehouse. And that's really the genius of Azure Synapse's architecture. It shifts the whole paradigm from one single overwhelmed machine to a highly coordinated team that works in parallel. If this deep dive was helpful for you, please do us a favor and like, share, and subscribe for more. It really helps. And it leaves us with one final thought. As our data just keeps growing and growing, is this divide and conquer model the only real future for analytics? Or is the next big architectural revolution already waiting just around the corner?